Welcome back everybody to the Fun Daedalus projects. Today we're going to be doing a couple cleaning up of loose ends that we've kind of accumulated throughout our whole project, and a couple investigations that we're going to need to do to determine why we got such bad principal results on our previous video. I wanted to separate this out before we do our final video, which is going to include all of the enclosure parts, but first things first, one of the things I really didn't like so far was, yeah, do you see that fitment is really bad. And the way this is all designed was to have enough space between all the items. So what I ended up doing is going into CAD and CADing up the same sort of like ultra low profile clip, and I extended this piece right here at the edge so that it could fit the PSU much better. And I found a all-in-one integrated version for the Raspberry Pi. So very happy about this. And the only thing I did was I changed it so that the screw points aren't heat inserts, and that there are thread forming screw inserts. Oops, thread forming screws. So we're gonna get that installed, and I will see you guys back. Just wanted to show what that would look like after it is installed, nice and low. And then on the Raspberry Pi, here it is, nice and low, looking good, great. And here it is, much tighter and much better placed. And it's great because I finally was able to get enough space between all of the parts. I really didn't want this to short on the SSR, and it's looking really clean now. That was a small detail for me. So as previously mentioned in the last episode, which if you guys haven't seen, I highly recommend you do, it will help my channel quite a bit. The link will be up here in the right corner. But as you can tell, there are some really weird artifacts that are going on here, and I want to do some investigating to figure out what could be causing these artifacts. They're very prominent on these flat walls and not so prominent on curved walls like on the benchy. So it's kind of a question of like what could possibly be causing this. Now I have three main suspects. The first one being that it could be the input shaper results weren't saved, and thus this is just normal resonance going on in the printer. I highly doubt it's this, but it's one of those things you might as well just do since you're already there. The other thing that it may be, and I kind of pointed to this at the last episode, was that I noticed that the idlers in the very front of the machine sit a little bit low or a little bit high depending on which side of the printer we're talking about. And we're gonna have to do some investigating to see if maybe the fact that those idlers are sitting at different heights are causing some weird wobbling effects in the printer. The other thing is maybe we can see if the idler stack on the actual motor is in line with the belt. There's a chance that maybe that could be the issue. And lastly, it could be the dampeners themselves, causing their dampening effect is causing the motors to move under load, which will transfer into the belts, which will transfer into the actual prints. Because dimensionally this is good, but there is a lot of wobbling here. So let's start off and try all of those things one by one. And we're going to print a cube. This is going to be our standard number 1 cube, and we're going to print them out with some more black PLA and see what the results are. Looking at the belts straight, there looks like these belts are a bit tilted in like that, and same with this side, it's a bit tilted downwards as well, just like that. And I think the best course of action to fix that is just to take this bar, move it up, and get it upwards until this whole belt is straight. My other suspicion is that this idler, which I don't think you can see, but this idler that I'm pointing at with my wrench, might not have the correct amount of shims underneath. So what we're gonna do is we're gonna move this up, which is gonna be good, and then we're gonna shim this bad boy and see if that is the issue. But my biggest thing is if I take this off, I might as well test the dampeners. So first things first, let's straighten out this bar, and then let's see if there's still a bit of a downward issue there, and let's see if that does the trick. Kind of hard to visualize, but I just adjusted this top bar, moved it up, and that did a tremendous amount of work in terms of making this thing completely straight now. And the other thing to know is that when you're tightening this bar, definitely have like a flat piece of metal or aluminum to brace the side so that as you're twisting it, it's not gonna wanna move and it's not gonna wanna rock in or out like this, you know. And that rocking will also determine some of the angle that this belt is on. Next up, you can see that the belts are running a little too high on this side, and can that focus? Oh, and a little low, or actually a little mid and low on this side. And what's funny is that that perfectly corresponds with how the belts are riding on this front idler and the corresponding front idler right there that you can kind of see in the dark. So we're going to go around and move those front idlers to get a very nice straight belt path and see if it makes any noise. Yeah, anyways, after retensioning or moving the belt holder idlers down and up to its respective position, and then moving the rear bar, this is the input shaper graph results that we're getting. We're getting a much more prominent second peak here, and you know, this is going to be kind of interesting. We're going to have to see what this second peak is. You know, my guess is that since it's in the Y direction, this might be just the cable chain, and there's not much we can do about that. So, and the only other way to really test it is to pull the chain out of the cable chain, the drag chain, and test it without that. But that is quite a bit of work just to see if this is that or something else. So we will probably go ahead and do that in a second. Once we get this done. But we did both the X and Y input shapers. This is looking really good. It's not looking much different than before. I did run this once before, and I was able to get 14,500 and to recommend me ZV instead of MZV, but for whatever reason it's recommending me this now, so we'll go with that. And I saved it. You know, I've got the bed preheated. We are going to print this Voron cube, and we're going to see what the changes did to the cube, and if we're still getting that repeating pattern on the side of the walls of the print. So we'll go ahead and do that, and I'll see you in just a second when this is done. All right, so I wanted to take a look at the prints that we were looking at, and like I was saying, this is the very first print that we had, and you can see some, you know, odd amounts of ringing going on, or some sort of vibrations being brought into the actual part here, which is kind of ruining the skin. So this is the print that we have after doing our modifications, which is after we straightened out the motor belt the motor brace, and then readjusting the positions of the front idlers, and it actually produced a worse print. Look at that. So the X actually looks much better, I'd say. Where is it? The X looks, I'd say, you know, marginally a little better. Maybe, maybe not. Hard to say. But the Y got substantially worse. So my suspicion is that as the motor bar was adjusted to be from, you know, let's say this is, let's say that this is straight up against the wall. You know, it was originally like this. Having actually aligned all of the belts, it actually caused there to be a much more direct transfer of any sort of vibrations going on. My assumption is that that motor bar or the extrusion was dampening some of the shaking that was going on, you know, possibly putting some odd tension in the belts, not allowing all of that to transfer. And you know, my first idea is that, wow, okay, so a lot of this is transferring in that direction. But as you can see, you know, if it was transferring directly, it should be in every direction. It should be both X and Y. So this is kind of odd. And so what I did is I took a print from my good 3D printer and to use it as a reference, right? So we can see it from the side. There is no vibrations. If we look at it from the X side, again, flat, no vibrations. The main thing is that, yeah, you can tell there's quite a clear difference in quality. You know, one looks like a flat wall like it's supposed to, and the other one looks like it's just having tremors. So yeah, this is interesting. The next thing that I want to do is I want to take the belts off, retension the belts, and while I'm there, I'm going to take off the motors and remove the dampeners and print something with just the dampeners off and see how good or how bad the print gets. So let's go ahead and do that. Let's remove the motor dampeners and see what happens after that. Okay, so some more interesting results have come up. So what I did is I took off the two dampeners from the motors here, and I decided to rerun my input shaper and to rerun the tests that we did. So as you can remember, this is our goal. Looks pretty good. This is pretty nice. This was our last one that we did, and you can see there's clearly lots of bending and lots of issues here. And this is our new one. So comparatively, it's looking much better, a lot cleaner, a lot nicer. So the dampeners did have an effect on the printer itself, and it's looking pretty good, honestly, pretty sweet. If we compare it to this guy, a little bit of an odd ringing in there, and you know, this took me a while to figure out. I think something we should do is compare how this looks up against the belts, which can kind of give us some inferences of what could be happening. So here we are at the printer, and like I've said, I did swap out the motors to fit directly to the actual item, or to the actual bar right there, which is really nice. And we did see some quality changes, but as you can see from this angle, there is a bit of a left-right pattern there. Do you see those vertical patterns? And I'm going to try to zoom in right here, but those left-right patterns seem to perfectly line up with the belt. So my growing suspicion now is that our belt is actually just old. So we've got an old belt that's been tricking us, and since we're going to be upgrading the belts to just a newer belt, we should also update a lot of these pulleys, these tooth pulleys, and these other smooth pulleys that are right here and here. And we will need to upgrade all of those items. That way we can start with a blank slate and see what's going on. Let's hop over to the input shaper graphs and see what they're showing us. Okay, back on the computer. So what I decided to do is to tension the crap out of these belts, because we already have them and I know I'm going to replace them like I was mentioning in the last clip. So let's look at the input shaper results from this. So we could see that in the X direction, we have almost, yeah, pretty much a perfect graph. You know, it is recommending me ZV. We can get up to 16,000 acceleration, and it's a sharp peak. You know, there's a little bump right over here, but that's pretty normal. We have a nice sharp defined peak. Now, if we look at to the Y graph, we can get a lot more information of what could possibly causing this issue. So we see that there is a dual, even a small triple peak right here. So this is supposed to be our main peak here, but we have a residual peak right here that's actually causing a lot of issues. and it's causing so much of an issue that it's bumping us all the way down to EI, slowing us down to 6700 for our max acceleration in the Y. If you remember our first test with our X beam in the wrong position, giving us some insane dampening effects that we were not aware of, we were getting up to 6900 acceleration. And that was with MCV. So MCV, ideally with us right now, with everything corrected, should be able to get us up to 8,500, which would be a substantial jump. But we are noticing that there is a large peak here. Now, generally speaking, this peak should be a sign that something is either loose. There is generally a bolt that should be loose, or a cable that isn't tied down properly. Something is shaking violently in this area. Now, this could also be a result of filament being in the actual tool head, but that's an easy one to eliminate. What we will do now is, once we have the belt off, we will take off the belt, and we need to, well, one, purchase a belt, purchase some idlers, and then go through the entire Y gantry and see if there's any place where there's a shaky or loose bearing. Maybe there is a I don't know, some debris somewhere that's causing something to not fit properly. Or what we can do is just troubleshoot and see what could be the problem. We should also test to see if maybe the cable chain is acting as our enemy here, causing us to move a little bit further and a little bit closer than we intended to. This would be a funny thing to find out that this is just the cable chain, but I kind of have my doubts. I feel like this is more a mechanical issue. Lastly, it could possibly be that the gantry isn't perfectly square, as in the rails are binding, but rail binding is a lot more auditorily clear, and this doesn't seem to be any of that. So we'll have to take our shot and take our guesses and see what else could be causing this. So let's see what happens. Okay, so something kind of gnawed on me before I wanted to make the purchase about the belts and the idlers, and I kept thinking about it, and I remember that there was this great video, and this is the video I'm showing now, by 3D printers and a whiteboard, and this guy does a great job explaining what could be going on when it comes to input shaper graphs. And we are so lucky to have an individual who is able to translate a lot of this mystery into something more tangible. And he gave a great example here of what could be going on with someone's input shaper graphs. And so if you guys remember from the last peak, which was this peak has a very definitive first peak right here, and then a very definitive second peak. He showed an example where something like this could be, people generally think, like I was thinking, binding, loose belts, over dampening, loose bolts somewhere, or just really bad printer design. And then he showed an example where there was an individual who had that same exact double peak as I'm showing you now, and he just said something funny and simple. He said a wobbly table. So that piqued an interest in my mind. Okay, like let's see, can we rerun the input shaper graphs and see what the results are? And I have done that, and I want to show you guys the input shaper results. So for X, this guy, we got MZV at 12,400. And for the Y, look at this, we got a ZV of 13,200. Funny enough, the X is now our limiting speed. So yeah, that was definitely the table. And all I did was I took the printer off the table and I moved it to the floor. And I suspect that there's the second peak here because the rubber feet are probably not stiff enough to handle this. So one thing that we'll do is actually just take some of the feet, and we will just replace them with some newer feet that are a little bit more stiff. They might look a little goofy, but a little stiffer feet. And we will see how this goes. I am thoroughly shocked and surprised that it was so easy of a change that it could just be moving the printer to the floor. So I guess the best thing to do now, looking at the X, is actually just to print something and see what we get out of the print. If it's super cool, good. And yeah, let's just inspect that and see where that leads. I wanted to show just a quick little video of our printer actually printing. And let's see if we can get it in frame. And that is looking really clean. Given that we have now moved our printer onto the floor from the table, which has been helping a ton with the dampening. So that'll be something to always remember with something like this, with a Trident style printer, or really any sort of top heavy printer. You'll want it to be definitely on the floor, or something with a heavy dampening force. Okay, so after our recent discovery, we have finally printed out our final print, and you can see here, this thing looks absolutely amazing compared to our other prints. And I really wanted to just to show this side by side. So this left one here is our leftmost print is our first print with the terrible belt positioning. Then we have here with the correct belt positioning. Then we have here our tensioned belt. And here we have our printer on the way right, with the printer actually on the floor, the belt's tensioned correctly, and you can see it looks stunning. It might not come up on camera as well as it does here. There's some weird reflections here. These aren't visible in real life, as you can tell. You can try. I'm gonna try to get an angle. Yeah, in real life, it's just like that. It's not wavy or anything. It came out perfect, dude. Absolutely perfect. And so it's kind of funny. We did all of that testing, and thankfully we found out that there were no broken idlers, that it was really a belt tensioning issue, which is great, because that meant that twofold, we could tighten our belts more considering we have the double shear mod. And I tightened all the belts to, I think, 175 hertz on each belt. So what you'll do is you'll take the gantry, you'll move it up halfway, and you will tighten the belts on each side of the inside to 175 hertz. And that's how I got these results. And I know that's very, very tight, but these belts should be able to handle it. In fact, it's way lower than what they're normally able to handle. So that's really good. And we are able to get these absolutely beautiful, beautiful results. Of course, the overhangs look good. Let's see if you can even see that. But anyways, yeah, the overhangs are good. The prints came out wonderful. They are dimensionally accurate, and I am very happy about that. I'm glad that we didn't need to, blow a ton of money on new belts and new idlers. Could the printer benefit from that? Of course, any printer will benefit from new belts and idlers. It was just an unnecessary thing for this printer, and if you can see it right there, look at that. Perfect. I wanted to show that again. Now you might be asking, oh, but what about the actual dampeners? Wouldn't that have helped? Well, I would have kept the dampeners if it wasn't for me accidentally shining my my thermal gun at the motors. So we currently have 2504. I think they're ACs. So these motors should be able to handle up to, around 90 or so C at operating temperature. And I took a thermal reading of them originally with the dampeners, and they were reading super high. And I'll show a clip of that now. And then I took a reading of it without the dampeners, and I saw that the temperatures dropped enormously, over 20 degrees C, which is a ton, meaning that can help extend the current life of the motors. So that is all. Thank you guys so much for watching my little surprise video. This kind of came up on me and sprang up on me without me really knowing it. My next video, I really wanted to finish up the enclosure and whatnot, but this kind of came up on me because it was just gnawing at me. I didn't like the print quality, and now I am much more happier with the print quality. It came out really, really good, and everything is going perfectly well. So yeah, thank you guys so much for watching, and I will see you guys in the next episode.